Hi, our group topic is naive Bayes, and these are all our group members. Hi, this is Raghavendra Yangal. I'll be discussing about Gaussian naive Bayes. These are all the topics we are discussing in this PPT. Basically, naive Bayes is a Bayesian classification which contains a statistical classifier which can predict using the probability, and a naive Bayes classifier is comparable with the decision trees and also with few selected neural network classifiers, and the accuracy and speed for the naive Bayes is very good. And coming to the Gaussian naive Bayes classifier, naive Bayes methods are set of supervised learning algorithms based on applying Bayes theorem with a naive assumption of conditional independence between every pair of features given the value of class variables. The different naive Bayes classifier differ mainly by the assumptions that they make regarding the distribution of training sets. And despite of all the assumptions, naive Bayes classifiers have worked quite well in many real-world simulations, like famously documented classifiers and spam filtering. And now we can perform code for Gaussian arrays by importing the sklearn package, and Gaussian NB is the we have to import from sklearn. Now we can create an instance by using Gaussian NB, and we can train the data by using gnb.fit, and now we can predict it using the predict variable. This is my quiz question. Thank you.
Hi, this is Sohan, and I will be discussing about multinomial naive Bayes classifier. There are two classic naive Bayes variants for text classification, and multinomial naive Bayes is one of them. And we use it mostly for multinomially distributed data. So when there are numerous classes to classify the text, we use this algorithm to predict the label of the text. We do this by calculating the probability of each label for the input text and producing the label with the highest produced probability of the output. So these are some of the advantages of multinomial naive Bayes. One is easy to use on continuous and discrete data. Other is it can handle a large data set, and it can classify data with multiple levels, and it is best to use the training natural language processing models. So this is the code for multinomial Bayes. So we import the multinomial naive Bayes from sklearn.naive Bayes library, and we create an instance of multinomial naive Bayes in this form, and we fit the training data of x and y using the model, and we can test the data by using a test data set and predict the output. So this is my question for multinomial naive Bayes. Thank you.
Hi, my name is Shashank. Here I am going to discuss about complement naive Bayes classifier. Complement naive Bayes is somewhat a modification of standard multinomial naive Bayes algorithm. Multinomial naive Bayes is not able to do very well with the unstable data, whereas complement naive Bayes is particularly suited to work with imbalanced data sets. In complement naive Bayes, instead of calculating probability of an item belonging to a certain class, here we calculate probability of the item belonging to all the classes. This is how complement naive Bayes classifier works. And then after calculating the probability of given instances not belong to it, we select the least value because it is the lowest chance that is not belong to the class. This means the most likely to be part of the class. So that is the reason why we select this class. And this is the code for complement naive Bayes classifier. Here we are importing a complement NB from scalar naive Bayes. And the next thing, we are creating an instance called classifier with complement NB. After that, we are training the dataset to classifier, that is classifier.fit. And here the last step is we are predicting classifier.predict. Okay, this is the question regarding complement naive Bayes classifier. Thank you.
Hi, my name is Rajesh, and my topic is about Bernoulli naive Bayes classifier. In this Bernoulli naive Bayes classifier, Bernoulli NB is the package name where it implements the naive Bayes training and classification algorithms for the data which is used to distribute it according to multivariate Bernoulli distributions. There will be multiple features, but each one is assumed to be binary valued variable. Hence, this class requires samples to be represented as binary valued future vectors. And the given equation is the Bernoulli distribution equation, where we have different values for x, where the values of x is either 0 or 1. And we have decision rule for Bernoulli naive Bayes classifier, and where is this is the equation. The example of Bernoulli naive Bayes classifier is explained here. For example, we have in the case of text classification, word occurrence vectors rather than word count vectors may be used to train and use this classifier. And Bernoulli NB might perform better on some data sets, especially those with shorter documents. It is advisable to evaluate both models if time permits. Here it is the code of Bernoulli naive Bayes classifier. We have 5 steps here. First step is we import libraries. For example, we import the package name Bernoulli NB here, and we calculate accuracy score. And by using matplotlib pyplot, we show the plotting graph. And in the next step, we create data and we create and train the model. And we predict an instance and we draw plotting graph. And coming to next slide, I am explaining advantages and disadvantages of Bernoulli naive Bayes classifier. Whereas it is fast and are able to make real-time predictions, it can handle irrelevant features nicely. And the disadvantages of this classifier is if there is a categorical variable which is not present in training dataset, it results in zero frequency problem. This problem can be easily solved by Laplace estimation. And here, it is the question. Thank you. And the next slide will be continued by Pawan.
Hi, this is Pawan, and my topic is categorical naive Bayes. So basically, categorical naive Bayes is a subpart of naive Bayes. So it implements the categorical naive Bayes algorithm for categorical distributed data. It assumes that each feature, which is described by the index I, has its own categorical distribution. Here, the probability of category T in feature I given class C is estimated as probability of x of I is equals to T, Y equals to C, equals to NTIC plus alpha by NC plus alpha NI. So briefly describing, the NTIC stands for samples in XI and class C, and C denotes for class C, and it is the number of samples with class C. Alpha is a smoothing parameter, and NI is the number of available categories of feature I. Categorical NB assumes that the sample matrix X is encoded such that all categories for each features I are represented with numbers 0 to n to I minus 1, where Ni is the number of available categories of feature I. Next. So this is the code for categorical naive Bayes. So initially we will import NumPy as NP, and after that here is the code for categorical naive Bayes, and after that we will import package from sklearn, that is categorical naive Bayes. And next, this is the question for categorical naive Bayes. Thank you.
Hi, myself is Jay Srinath. I am going to discuss about out-of-core naive model fitting. Basically, out-of-core typically refers to the processing data that is too large to fit into computer's main memory. Uh, Generally, this is going. It's a data set when it is a large. Uh, in the naive models, we cannot actually tackle those large classification problems with this data set. So to handle this, we use multinomial naives and Gaussian naives and Bernoulli naives, which exposed to the partial fit method, which is used to train the data on an incrementally basis. The main sketch of this system is to design stream instances and way to extract the features. And the best example where this technique is employed is text classification. Uh, Text classification of the documents where typically the size is very larger. And here is the code for the classification of the text documents. And first we import the libraries from this which utilize scikit-learn, and we create a vectorizer and initiate it, and more and thereafter we uh, initiate the classifier and then plot the graph. And moving to this is my quiz question, and thank you.